my channel. In today's video, we'll talk about logarithmic scale. It's used when data values are extremely different in size. Instead of increasing by equal amounts 1, 2, 3, 4, etc., a logarithmic scale is increases by the power of 10, like 1, 10, 100. So increases the power of 10. This makes very large and very small values easier to compare on same chart. For example, if we talk about light year distance, star A, if it's 35 light years, and the star B is 9760 light years, and the star C is 12500 light years. Let's say this is our data: star A 35 light years, star B 9760 light years, star C 125000, and star D and galaxy E light years. And if we see this data in graph, insert and the graph, so this is how it is, like all the stars but the galaxy E stars, which is like dominates the chart. So these smaller values appear almost flat, in this largest value dominates the chart. And what if the same value, and then we format our x's, and the same chart, if we put in the logarithmical scale, so this is all points easier to compare, right? And they are visible because instead of increasing the number 1 or 2, this increases by the base value is 10 by the power 10. So if star A is 35, so it's here, and the star B is near about 10,000, and star C is, so this is all increasing the power 10, so easier to compare. This is the logarithmical scale. So this is logarithmical uses the data when there is several powers of 10, like in the example light years, galaxy distances, bacterial growth in biology, in chemistry concentration and pH, and in finance company sizes and market values, and also population studies. So avoid it when values are relatively close together, because normal scale is easier for the most people to understand. So this logarithmical scale displays the data using powers of the base, usually 10, instead of the equal increments. And it is useful when data contains very large or very small values, because it makes comparison easier and prevents smaller values from appearing insignificant on the chart. This values not showing any insignificancy, because if we so I just take out the logarithmical scale, and now so these smaller values, no significance, they are showing insignificant, not easy to compare with the galaxy, but with the log scale it is easy to compare. So always remember, when your data contains values that differ by thousands, millions, or even billions, this log scale can help reveal pattern that a normal chart might hide. Let's take another example, a very simple example. Let's say this is a YouTube channel, and this is a subscriber, channel A, B, C, D, and E. You will see, so this subscriber dataset is increasing by the power 10, right? So this is the normal scale, right? So all the smaller values showing no significance, they are showing like disappearing on the chart, right? No comparison with the channel E. But the same data, when we are using the log scale, is showing the comparison like this linear chart, right? So this is the power of the log scale. When we reveal the pattern and then the smaller values also um, appear on the chart and then reveal the pattern, and you can tell there's a comparison between, so between the channels, between A to E channel. So how much comparison? Because if you see a normal chart and A, you're like, how much comparison? Like no comparison between channel A and B, right? But here in between channel A and B, there is a comparison, the power 10. So I hope you understand the concept of log scale versus normal chart, when we can use the normal chart, when we can use the log chart. So always remember, if you want, if your data set has the larger values or even the smaller values, then you can use the log scale chart. And if the values has small increments, increase or decrease, then you can use the normal chart. Thank you for watching. Don't forget to like, share and subscribe. Follow for more such videos. I will see you in the next video with a data analysis concept. Thank you.